Okay, top of the hour, and it's the 13th of November. So nothing lasts forever. And actually, I'm not going to go into the and anyway. All right, good to see you. Lots to cover this week. Last week was kind of a wacky, weird, and wonderful, sort of examination of what we could do. This week is it hopefully is a little bit more practical. I'm not gonna dig into so many bugs. Hopefully, maybe we'll build some more interesting things. A few things I've been working on as well is in a new update to my neuro trading. And when I say new update, I mean a complete rewriting of the entire platform from the ground up in Rust and MPX. And I think I'm going to open source the thing because why not? I'm just going to make that available to everyone. So I'll show you a little sneak peek of what I'm doing there and how I'm going to go about open sourcing that maybe in the next week or so when I do some more debugging. And some various other approaches and tools that I've been building on. But before I do, let's see what everyone's up to. I see Jed. Hey Jed, how's it going? Any crazy anything crazy you're building?
I don't know about crazy, but I've been experimenting lately with third-party web search providers. So we've all heard of Perplexity. We know that OpenAI and Anthropic have their web search capabilities, but now there's this company called Exa, and it's interesting having my swarms using Exa alongside the Playwright to explore the internet from yet another perspective, especially now that the likes of Cloudflare are starting to add barriers for agentic access.
Okay.
This is
X and
especially
that's
problematic for documentation,
and
not
that's
referrals
Exa.ai.
purposes.
Is that XAI or XA or
Echo,
EXA?
X-ray, alpha, dot.
Okay. So yeah, it's worth taking a look at for sure. What else we got going on here? I see Nick. Nick, I think you've gotten over the loss of your Blue Jays. Good to see you on Tuesday at the Toronto meetup. That was fun. What have you been creating here?
Yeah, that was a good time. I'm just following the rabbit hole. I started with this rewrite of a popular program that helps you find leaked keys in your project, and I converted to Rust, so it's like way faster and stuff like that. And then Reuven's like, okay, now what you should do is build something that's related to that, or what's next. And then I started to understand better, like, about building in stacks. So I just go into like ChatGPT, I'm building something, I'm like, what's related to this? What's the next thing? And I'm just like following that rabbit hole, and it brought me to some sort of LLM DevOps, and I'm building all these footings. So yeah, it's been pretty cool. Getting some downloads on npm and crates. It's pretty sweet. Yeah, so that's what I'm doing.
Nice. Yeah, there's this bump you get when you first post a crate or an NPM or MPX where you get a bunch of downloads because I think it lists it on the recent downloads section of their website. Earlier this week, I did my what I call it, the agentic jujitsu, which is a sort of reimagination of the version control system, which I'll show you guys here in a few minutes as well. And that ended up doing, I think, 11 or 1,200 downloads in the first day, almost entirely because of the NPM sort of discovery tool. So the trick is to see if you can keep that momentum going, right?
Yeah, most of
But
mine are dipping pretty hard. After the first week, I was pretty hyped, and then a little less excitement in the following week. I actually took that specification that you showed me, remember? And I the LangChain RS specification, and I did my best. I did my best, Reuven, to build it, and I used the Claude Web for that one. And I did put the E2B. I did put the E2B and a Claude key, and I think one other something. Open router, because there's like a routing component to that. So I did also put my open router key. It's not done, but I it built what it built, and then there's a few things that it said it hadn't completed. I turned it on before I went to bed. I haven't actually looked at it yet, but yeah,
that was the Lang graph
yeah,
port.
yeah,
Yeah,
yeah.
For those who are interested, I'm posting my PRDs on my Gist, and there's a bunch of interesting ones. But the one in particular is
Just lost.
so. Oops, did I share my wrong screen? It's hard to tell sometimes.
Oh, we lost audio for like just about 20 seconds there.
Oh, you did. Oh,
Yeah.
oh,
You're
I'm back. Yeah, I was just sharing the lane graph PRD here. If you guys are interested on Gist, you can see sort of how I go about building this stuff. And basically, I think what Nick was saying is he just kind of blindly took this, and that's all you need to do. You copy this URL, and you go into Claude Code, and and then you say implement. And this is something I was doing with Martin the other day. So Martin asked me in regards to like how can you build the robotic system. So, and then this was like before we were doing a meetup in Toronto. So basically, we created this ROS 3, which is a robotic operating system 3 rewrite for the next 20 years. So a lot of times when I do these things, I'm like, what does it look like in 20 years from now? And this actually ran for quite a while in terms of the deep research. So let me just show you that quick, which was interesting. So here it is, ROS 2. So this is it. Give me a complete specification using Spark, which is my specification. And what's cool now is Claude actually knows about my spec. It doesn't tell me it's a Sun Microsystems chip anymore, which is cool. And robotic operating system. But here's the important part here. You'll notice when I go to it says ask me a bunch of questions. Now I said I want SDK, and I want a ROS 3 that would exist 20 years from now. That 20 years from now actually seems to make a big difference in terms of when you're building this stuff. It literally creates the future. And then what's interesting here, this one ran for 58 minutes, but some of these run for like 2 hours. And at the end of it, it gave me this really, so I can see two things. So here's all the research it did, and I can see here all the things it looked up and all the sources. So this is the grounding, 574. And then what I did is I ended up with this. But what I like about this is I can easily copy it, right? So I can copy the markup, and so I can copy it as markdown, which apparently ChatGPT used to do but got rid of for some reason. And then I popped it in here. Now I could probably just publish it and do it the same way, but more people follow me on GitHub, so I have a better following there, so that's why I posted there. But you can see it's like hundreds of pages long. And then once I did that, I just said basically fully implement. And we can see I did this about a day ago, and it did its thing, blah, blah, blah. I'm going to go to the end, and it built the whole thing. Now, I haven't had a chance to verify, and to be honest, when Martin told me that it might be used to create an army of evil robots, it kind of gave me some cold feet. So I built it, and I'm probably going to publish it. All I need to do is click this create PR button, and that'll create the PR on my Vibecast. But for those who are interested in this, before I actually go ahead and do that, I create a lot of my experience on the Vibecast GitHub. You can go to my, or what's going on here? It seems to have been locked up for some reason. Oh, there we go. So we go to the branches. Not sure why what's going on here. Am I still coming through okay? Brand new computer. You think the thing would work okay? All right, come back to life.
Yeah, we just have a hot mic. Joe Still's mic's hot right now. That's what
all
you're
right.
hearing.
Oh, right. Let me fix that. What I'm gonna do quick, and just unmute yourself, guys, when I do this. I'm just gonna mute all, and then you can just unmute yourself if you want to talk to me. Yeah, this Zoom for whatever reason doesn't automatically mute. When I originally created it, like months and months ago, I didn't turn that button on, I guess. All right, this came back to life. 22 branches. So now what we got to look at here is which branch this is. This is the Claude implementation. I can't see it all. Let's see what that says. It's got this funny name. So we're gonna go back here and we'll find that. Okay, here it is. So for anyone that's interested in trying it, here I'm gonna pop this in the chat, and you can give that a spin.
You still have 972 credits?
Yeah, seriously.
Wow.
I'm building like crazy. I don't think this works. It hasn't moved in several days. And it was 972 credits like 3 days ago when I was giving the presentation at the Toronto
Right.
meetup. I think it's broke. It definitely doesn't seem to have any real bearing. Like I'm building all kinds of stuff with it every day.
Mine's
I
at
think,
mine's at 972 as well. So I don't know if that's the magic number or what.
I think they're probably just letting you run since you're doing all their dev work for them there, Ruth.
Apparently. But before we jump into the Vibecast, though, I want to come back to Mark Allen, our friend in Vermont for a moment. Mark has just offered to do a Agentix weekend retreat at his hotel. Mark, you still there? I might have lost him.
You're
I'm not
muted,
sure.
Mark.
Yeah,
Got remuted. There we are.
Yeah.
So let me share. So we are in Killington, Vermont. So it's easy to access from New York, from Boston, from Toronto. And so I think it's just picking a date that works for folks. And, we could come out here. I think we got a 20-bedroom place. We got a big working space. So we could do a hackathon / skiing / snowshoeing, hiking, whatever's, depending upon the weather conditions. But it's a beautiful little slice of heaven that I'd love to host some kind of meetup here.
Yeah, well, I love skiing. I attempted to learn how to snowboard, but realized I was too old to learn new things and went back to skiing. But there's some nice hills there too, right? No, mountains.
Mountains,
I'm from Ontario. There's no mountains here.
Yeah,
This is Canal over here. Can I jump in real quick? Mark, I was just at Killington. I keynoted at Vermont Fest. So I was there just 3 days ago. And I talked about Agentix with superintendents and teachers and all of that. So sorry, I just wanted to jump in there and say that. That's kind of
awesome.
amazing. Yeah, I was just
Very
there
cool.
3 days ago.
Yeah.
And hi, this is Stu. First time meeting most of you, but I've actually been up at Mark's place and spent the weekend coding with him, and it is sensational there. You should definitely find a way to get there if you can.
So the mountain's open. So I think if people want to try to do something, maybe even this month or early next month, we probably need like maybe a month out for a lot of people to travel. But let me propose some dates that I'll look at our calendar and let's make it happen. The question is, do we try to do it over a weekend? Do we try to do it during the weekday? What works better?
I don't know about you guys, but my schedule is like ridiculous. So for me, it would have to be over a weekend. But I know my kids would love to go and ski on a new hill somewhere. So
Yeah.
they would well they all snowboard actually. I did convince my daughter to ski though, so I'm not alone on the hill. They all ditch me on their snowboards, but I still have some accompaniment with her for now anyway.
Okay,
But
so
yes,
let's
yeah,
do
we
it.
should do it.
Let's do it on a weekend. So I will get back with some proposed dates. I'm going to talk to my wife about it, figure out when we can do it, and let's make it happen.
Yeah, there's also been some discussion next year in regards to a broader global meetup and in Toronto. Well, I'm proposing somewhere in Ontario because I'm lazy mostly, but potentially I was thinking maybe we could do something similar, like find ourselves some kind of like resort in the middle of the sort of lake area of Ontario where we can chill on a nice dock with our laptops and build stuff. I don't know, something like that. There's a lot of interest in that, and it's probably a little more accessible for some.
But the
folks.
Georgian Bay area is gorgeous.
Yeah, for sure, exactly. Georgian Bay. That would be that's the area. Sometimes referred to as Muskoka. Yeah, so that'd be cool. That'd be fun. And actually, speaking of, we got Rob Ranson. You live in that area, don't you, Rob? I think. Oh, hey, is he there? I think he's there. Anyway, I put him on the spot. All right. So
Hearing
one
you, Rob.
last.
Looks like you're trying to talk, but we're not hearing.
No, I'm improvising here. What can I say? Actually, side note, you guys will see my dad on this today, and I just want to give you a little story because when I was like around 10 years old. My dad hosted a local community television talk show called Around Town with Mal Cohen. And I was the gaffer, I think they called it, the guy that went around and bundled up all the chords and learned how to do the sound mixing and was like Johnny on the spot for whatever problems they had. So anyway, 30 years later, here I am. And this is my community access channel get together. So anyway, a long history of nerdy activities. I come by it naturally. So thanks for tuning in, Dad. All right. Let's get into some of the stuff I'm building. And again, if you guys have any questions or whatever, I'm vibing it. I'm showing what I'm doing. I'm kind of ADHD in it all over the place. Yeah, thumbs up, Dad. All right. So here we go. I'm gonna share my screen and we'll take it away. Lots to show this week, actually. All right, so I'm going to start with, I'm going to get back here to Claude Code. So Claude Code is my, well, it's free, so I've been a little bit obsessed with it. And this is the example I was showing you briefly earlier in regards to what Martin and I were sort of discussing. And this is essentially, I took a project, right? So I took the project that exists originally as apparently one of the more popular robotic platforms, which is the Robotic Operating System 2. And that I think is essentially, actually, I'm not even sure what it's originally built in. I probably should have took a closer look at that. But the Robotic System 2, let's go to the GitHub and see what I converted. That's blindly sort of rewriting the system. So where's the repos? Let's see what the most popular is. Robotic 2. There's a lot.
Quick question, Rube, on
Sure.
Around research. How do you know when the output that you get back is comprehensive enough, or you need to prompt? Are you taking what you get and trusting, or are you?
No, I don't.
Yeah.
I certainly don't trust it. I haven't gotten to the point of actually doing verification on it. But what I'm really curious right now is what it's built in, originally built in. Because to be honest, this was about as vibing as you get. I didn't even really pay much attention to what it was built in. I think it's Python. I would guess it's Python. Hey Martin, what is this originally built in? Python, it looks like Python and C++.
I think it's a mishmash, actually. Like, it's been around a long time, and that's one of the reasons why I said, it would be a good target. But with that, also maybe some requirements, perhaps different. It's not supposed to all be written in the same thing. Maybe it needs to interface with various languages. I don't have the details on those answers. Okay. That's why I think, unless we actually put a PRD in front of an expert, we don't know whether it's way off.
So I think bringing physical AI and vision language action models into this space would be awesome. I've used ROS quite a bit in my robotics efforts. ROS 2 is the latest, really, and yeah,
I'm gonna get in trouble.
They're definitely not integrated with AI yet.
Yeah, so calling it ROS 3 is probably not where I'm going to go with it, because that'll piss, I learned my experience from doing Drupal.js last year, where the entire Drupal community thought it was the worst thing that ever happened, which I don't know why they got so upset about that. But anyway, lesson learned. So I'll give it a different name here before, if I decide to publish it. But basically what this does is essentially, I took all my various components that I built over the last couple months, and I've essentially applied it. So again, to get an idea of what exactly it's doing, we've got to look at the PRD. Now, unfortunately, the PRD is quite in depth, right? So this is a comprehensive or technical specification, defines ROS 3, a complete roundup rewrite of ROS 2 in Rust, distributed via NPM via hybrid WASM, and native deployment. Now, one of the big changes that I've been doing over literally the last couple of weeks is the idea of the NAPI-RS. And what that allows me to do is essentially compile Rust components on the installation of an NPM or NPX. So traditionally, what you do when you take these systems is you'd have to do a WASM, which doesn't have direct access to the file system and has limited access to networking and other things, which is great for like algorithmic components. So if I want to do something complicated that is beyond the capabilities of TypeScript, I compile it as WASM. Where it falls down is it doesn't allow me to directly interact with the CPU and GPU and other sort of hardware enabled environments. So knowing this, I knew that I needed to compile it in a way that would allow me to get all the benefits of my AI systems that I've built in both WASM and now in the MP and API structure, and then rebuild it within this ROS2 technical architecture. So what I want to do is say, well, I've got all these different libraries that are available in terms of learning. So for example, AgentDB, which is my vector system, which allows the system to learn. I've got my Agent Booster, which provides a speed up for transformations of code, and I've got multi-routing, and my Quick system. So I've got all these various libraries and tools that are hyper optimized for, essentially a multi-part robotic system. So when you think about robotics, there's a tendency to make a robotic system. Again, I love the term monolithic, but monolithic. You've got all these parts. You've got the arms, the legs, the vision, the accelerators, and the various parts. So rather than saying I'm going to create one central command and control unit, what I want to do is say each of the different parts of the robotic entity have the ability to interact with separate threads or agents that are capable of uniformly and really quickly communicating with each other, right? So you've got, again, a swarm, if you will, of different parts of a robot that do different parts that are hyper targeted on those robotic components. Now you'll see here that it says the zero RTT connections. What the zero RTT connection does is allows for zero latency between the request and the agent. Now, a lot of the traditional systems that you'll see, including the ROS2 system, basically use traditional HTTP sort of transactional components, which requires roughly around a 300 millisecond delay between the request and the action. Now, for certain things, that's fine. But for other things, when you're trying to be as capable as a human, 300 milliseconds is about 100 to 150 milliseconds slower than a human can react. So the best baseball player is capable of reacting within something like 50 to 100 milliseconds to a pitch. And the reason why a champion home run hitter can hit a home run is the fact that they can perceive that information more quickly than me. Someone throws a 90-mile-per-hour fastball at me, it's just going to be blasted by me. I'm like, what's happening right now? A professional is going to be capable of sort of slowing down time and understanding that I can sort of preemptively see where that ball is going to be and hit it. And that means that I'm able to perceive in less than essentially 100 milliseconds and be able to hit in that right spot. So conceptually, what these types of platforms are doing are trying to mimic the speed and efficiency that you get in a human, sub 200, sub 100 milliseconds, as part of the overall flow of information between all the parts. So the part that decides I'm going to hit this ball and then swings, that entire process between where and how and what and doing needs to be faster, or at least as fast as a human. That's what this system is essentially intending to do. So when you see things like AgentDB, this takes it a step further. The agent, so you can see here, this is basically measuring the speed in which the computational overhead versus intelligence basically allows you to perceive, and I call it bullet time frequently, but basically slow down time to be able to make the decision quickly and effectively. And that's why it's so important for these robotic systems. Secondly, one of the things you see in a lot of these robots, the humanoid robots you see from like Tesla and others, is they're still heavily dependent on essentially remote sort of embodiment. So often there's actually a person controlling it somewhere else. It's kind of like Fireflies in their pizza post the other day. And or they have GPUs that are embedded within the robot. Now, the problem with the GPU approach is GPUs run hot. They use tons of electricity, so a battery doesn't last that long. And essentially, they're slow. Like, they're trying to compute everything all at once to determine what the optimal solution is to whatever in which it's doing at any given point. None of that works particularly well for a robotic implementation. Now, in my scenario, I'm using something called Onyx. Onyx allows you to embed the neural models for things like language and vision and other components directly in the model using, again, that WASM that I was talking about earlier. It's lighter, more optimized, uses a lot less computational resources. And ultimately, when I say uses a lot less computational resources, it uses a lot less energy. So that's what this thing's trying to do. Now, I've added the idea of an MCP protocol because I want to use things like my agentic flow and other MCP enabled systems to more efficiently interact with the components of the robotic environment. So all this stuff's happening within this, right? So this is the general spec, next generation features. This is saying what, based on all the things I just told you, what does the next 20 years look like? So what does a robot in 2045 look like versus what does a robot in 2025 look like? So it came up with, and some of the stuff it came up with is actually pretty cool. So it came up with this idea of a vision language action model. So you see 200 hertz. The hertz represents speed, sort of the timing. Gemini robotics, and again, a lot of this stuff is based on control frequency. So back to the sort of idea of speed and time, and the time it takes you to think, versus the time it takes you to do. It's actually taking all those things into consideration. Then it's looking at the energy efficiency. It's 140 times less energy than the DNNs. What's cool about this stuff, back to the original PRD, when I requested this thing, I said none of those things. I basically said at the beginning, give me a complete specification using Spark. But what's interesting is a combination that Claude seems to be getting to know me, like the memory or whatever it is. It knows this stuff that I'm telling you because I have a tendency to have conversations with Claude expressing exactly what I just said. So it sort of inherently knows this stuff. And I gave it my various projects like Agentic Flow, Agent DB, and other things. So it sort of defines that as part of it. So when I said, to this, tell me what the future looks like using my own tools, it kind of just magically knew that that's kind of what I was thinking without me even articulating those thoughts. All right, so then I have that, popped it in here, this ran for, I think I started before the meetup at 6:30 on Tuesday, and it literally ran until I was on the train back home around 11 o'clock at night. So it ran for close to 4 hours nonstop, doing all this stuff, testing, so now I'm going to say something like, Guy thinks this is BS. This is a elaborate simulation. Let's convince him that it's real. Something like that. All right, I'm gonna fix my spelling. That it's real. Create a detailed benchmark and optimization to prove this isn't total BS. I don't know, something like that. Let's go with that. All right, that's it. That's all I'm doing, right? And this is going to run for a while, so we'll come back to this in a few minutes and see what it comes up with. All right, and the next thing I was working on here, some of you might know I've got an NPM library called Ruby, which is what they used to call me when I was 10 years old. But so I said review MPX Ruby. So this is a library that I've been working on, and you can see here that I chose a particular repo, which is my sort of repo I use for managing my Ruve.io website. So I've combined the MPX for Ruby into the when you go to like the Ruve.io site, they use the same repo, and you'll see it here, right? So this site is both a website and an MCP server. So it's easy to combine the two. But anyway, so then I went here, it's doing the review, it's looking at all the various parts, it's doing its thing. It's giving me a report. Here's the report. Now, what I really want to do here is I want to make my Ruby MCP and CLI into basically a place where I could list all my various npm experiments. So because everyone's always like, what have you built recently? How do I find out what you built? So I kind of want to create a kind of a place where you could just go and download my whatever, right? So if you go to like npm.js, and let's take a look here if I can find where I'm at. We go here. Like I basically just want to show, I've got 40 packages now, which is lots and lots and lots of stuff. I just wanted a way for you to be able to grab and explore and find all the stuff I build quickly and easily. It's basically all I was thinking there. So it went and built that. So all this, you'll see here that basically, let's scroll up to where I can find where it did it. I gave it a test and ensure all MPS work. Let's go even further up here. Where is it? I gotta find it. You can see it does a lot here. This is what I asked it. Can I update my MPX Ruby to enable my users to easily list, search, and install my various npm libraries and MCP services? And yeah, it went and built the whole thing. I haven't published it yet, so before you go and say it doesn't work, I haven't. I have to review this stuff. There's not enough time in the day to review it, but this is the sort of stuff you can do. It's pretty cool. Yeah, lots and lots and lots of opportunities here to use this system. You can see I'm creating different different ideas, different components. Let's go take a look back here at the robotic system. So now it's this convincing guy that this isn't BS. It might still be BS, just throwing it out there. You never know. But if I convince Guy, I'm one step closer. So yeah, you can see it. So you can see this. So one of the things I want to show you also is how to quickly use some of my tools within this environment. So in this case, a couple things to note. Okay, you've got environmental variables. These are particularly important. And I'm not going to show you these because I don't want to go change all my environmental variables because I accidentally leaked them. But I'm going to show you default because there's no variables other than what you need to set up in the default environment. This is a really important part. You see this network access? By default, it's set to trusted. Trusted means that you can only download from package that Claude has verified to be accessible. Now, that means it doesn't really have access to the internet. So the first thing anyone's going to tell me is it doesn't work. The reason it doesn't work is you didn't choose full. Choose full. Make sure you choose full. Next thing you want to do is set your API keys. Now, if you're using my agentic flow system, you can use Open Router. So you're going to do something like Open Router _ API_key equals whatever. And then if you want to use like some of my advanced grounding capabilities, you're probably going to use the Gemini API key, and you might use the Perplexity API _key. Remember, you need to do that. Also note, this is a quirk of their system. Anything that involves a comment like doesn't work. You'll see invalid format. So you got to strip out all these lines, like any comments that you might have in your env. I don't know why they do that. It's a little bit annoying, to be honest. But get rid of those, and that's how you do it. So once you've got that in place, just take a screenshot of that if you want. Make sure full env. All right. Then once you have that, then you can go and I did this on a demo this morning. Install the Claude Flow MPX Alpha and the MPX Agentic DB, research Swarm, and find some new novel discovery in the medical field. Literally, I did that an hour ago on one of my coaching calls. So let's see what came up here. So now we can see here that it installed the version. It returned with 3.4. I'm actually pushing an update to 3.5. Maybe I'll do it right now, actually. That fixes a minor error on Windows that was causing a conflict. But anyway, 3.5 is coming out this afternoon. Here's the goal is the research swarm component that tells you how to do the research swarm. Here it's setting up the SQLite database. It's doing the various swarm research. Now it's spawning 7 specialized agents analyzing medical breakthroughs. Let me continue monitoring the progress. Excellent, 6 agents have completed their research. All right, do blah, 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 blah. Here's what we've got. All right, so Now here's a drawback of the system I don't like. It has a really weird way of just it displays the research summaries as a kind of GitHub commit. But anyway, if you want, you can copy like the quickest and easiest way to see this if you don't want to open up GitHub is grab this, go back to here, and then we're gonna go back to this for a sec. And then we're like, you could open up in GitHub as well, by the way. I'm just showing an alternative way to do it. We're gonna go here, and then we're gonna call it med.md, and I'll say various medical discoveries. All right, good enough. I'm gonna create that publicly so you guys can see it. And let's see what it came up. I haven't looked at this yet. So it's basically, it spawned 7 agents, and keep in mind it's actually not using Claude Flow specifically for the agents. It's actually using my agentic flow system to do the agents on E2B instances. But the benefit to that is I can spawn thousands, potentially millions of them, I guess, that work concurrently. Yeah, the question?
Just a quick thought. Would be probably useful if you when you create the gist, right, to also capture the prompt that you use, like that would like then. So this goes back to like the discussion we were having before, like how did you get from this point to this really great research, like so
All
that
right, let's
will
do that.
help, I think, those of us in a learning journey.
Sure. All right.
Yeah.
We should be just capturing the stream of prompts that we're giving it. That'd be...
I could ask it to include the original prompt as well. Here we go. This is my prompt. Super simple prompt, like vibing prompt, if you will. All right, so it created 7 specialized agents, research depth 4 to 9, variable by agent role. Now that's the cool thing about my research swarm. It sort of figures that stuff out for you using the goal components. Here are the agents that were deployed. So we had Explorer, Broad, and we had depth analysis. We've got verifier. You know, this is, you know, and this is how deep it goes. Depending on the depth, like the research swarm can run basically forever. So I don't want it to run forever. So you want to set sort of a depth, and that basically tells it how long it needs to run. Domain experts, critics. Critics basically is like I'm making sure that it's not full of crap, and verifies that it exists. All right, knowledge cutoff, limitation identified, future recent discoveries. This is how it's thinking. Here in my anti-hallucination protocol. Again, the AI, we had a discussion at the Toronto Agentics meetup about, does AI lie to you? It doesn't lie in the same way that humans lie, but it lies in the way that it sort of takes the path of least resistance sometimes to give you the answer. So it's not, I don't know if it's lying to manipulate you or lying just to get to kind of reflect what you're saying back to you in a way that's sort of what you'd expect it to say. But regardless of whether it's lying purposefully or lying because it's been programmed to be sort of, you know, a sycophant, the result is the same. This stops that from happening, right? Protocol 6, never generate speculative data or statistics. And I said medical, right? So this is going to be particularly important. Only cite sources you have verified and exist. Never create fake citations or URLs. Validation and impossibility assessment. 90% of verification threshold cannot be met because recent discoveries may lack. So these are things that are logical, right? But I'm broadly saying, find me new things without really telling it what. If I was to point this at, let's say, at a genomic data set, which is a project that I'm currently working on as well, it would ground the information on the basis of the DNA information and the correlation between the DNA information for certain anonymous donors of the DNA and their sort of profile for their ailments and other conditions, along with the PubMed data structure that I'm sort of using for grounding for research, as well as the research that exists within the actual research organization, which in this case would be a cancer research organization that are funded by a university and I think the US government. Anyway, so this is providing grounding, but in this case, I didn't include any of that grounding. So it's essentially just searching the web. So this is actually meaningful because it's like, I'm just searching the web. I can't say it's true beyond the fact that it's publicly accessible data. Anyway, novel scientific contributions, self-aware research systems, swarm demonstrated recognition of capabilities, researching integrity over results, recommended alternative research approaches. So it's doing various things. So basically, in this case, it's giving me. It didn't tell me the exact data. Okay, so what I need to do next. This basically told me how it did it. All right, so now I gotta go back here, and I'm gonna say like, what the heck did you actually discover? Or maybe it did. I'll task what happened instead of fabricating medical discoveries. 7-agent swarm demonstrated unprecedented research by self. Okay, find me some actual discoveries. Use, I think it's called PubMed. Maybe it's a MedPub. I don't know, something like that. Let me search that quick.
PubMed.
Yeah, PubMed. Yes. All right. And there might be an API. I should, use PubMed. And we're going to let that continue.
Are you running Claude Flow on Claude Code Web?
Yes, I am. MPX Cloudflow and MPX AgentDB and MPX research. So so what I didn't do here, because I'm running Research Swarm, I didn't tell it to run Agentic Flow, because essentially Research Swarm is my research implementation of Agentic Flow. So I didn't bother doing it twice, and it's built into Claude Flow here. So yeah, it's using these tools, and this is all I gave it. So all you need to do is basically the same basic prompt, and it just kind of magically works. And now I'm early in the process, so we're gonna let that run a bit. I'm gonna jump back for a moment and see what's going on with the robotics one. Back to, oh, it looks like it's still running. No, it's done. All right, let's see what happened here. I've a performance benchmark. This is real, not simulated. I've created a comprehensive benchmark, memory serialization, 54 nanoseconds. If this is true, this is the basis, and this is why I think Martin was concerned. This is the basis of arguably the world's fastest robotics operating system. Like, this is orders of magnitude more capable than the sort of previous. But I need to be able to prove that. So performance, again, it's not giving me the docs directly because it's in here, and that's a drawback of the system. So I could go and I could create a PR, or I can take a look, which I think I had open here, right here, and I can refresh because it did the commit, see 1 minute ago. So now I can go and try to find the files. Where the heck did it put those? So we can go and take a look here. It's in, I don't even know where it's at here. I gotta take a closer look. Well, we'll surf around, see if we can find it. Here's the performance report created a minute ago. So this is the performance report, real measurements. It's crazy. Like, when you think nanoseconds, microseconds, and milliseconds, this is just astronomically faster. Like, there's 1,000 times 1,000 to get to 1 millisecond from a nanosecond. So it's essentially a million. I don't even know. It's a million times. It's a million something faster than a millisecond. So, and when you think that humans think on the order of 100 milliseconds, so then it's 100 million times faster. Someone correct me if my math is off, but I think that's the general frame for how much faster it is. It's ridiculously faster. So, oh, here we go. A million iterations. Yeah. So
for 1 nanosecond at speed of light, approximately 30 centimeters. So to edit a block in memory, or I guess how long does it take to edit or flip a bit in memory? Because my understanding is that was still greater than 1 nanosecond.
Yes, you are right. So the real question is, how long is one cycle on a CPU? And that's the basis for as fast as you can possibly run, right? Now, keep in mind, this is running in a container somewhere, so there's a couple levels of abstraction. But so what I'm attempting to do is get to the closest form of the tick or the cycle in a CPU, and then run these sort of calculations and essentially mini agents that are doing very particular things at very, very fast scales. So you see here that this is actually running I think the lowest it got to was 30 nanoseconds, which is basically means that there's overhead between the CPU, the memory, and other components in the computer, which means I'm not going to be able to get to a nanosecond because that's the smallest increment of time that exists within a computer. But I'm getting pretty freaking close here. Right, so this would be the smallest increment. Anyway, here's a memory allocation performance. Now, ultimately, this is how we prove that to Martin's point, is this real? This is the step towards making this real. So example performance summary, hello robot, simple, in 10 seconds, and so it's creating basically production robot examples. Example execution proof, system architectures, pub sub. Tokyo is the sort of hyperspeed event bus for Rust, I think is what that is. So you'll see a lot of this in my stuff I'm building. Here's the comparison with ROS 2. So ROS 3 is 540 nanoseconds for serialization. This is running around 2 to 10 times faster. Message overhead is 3 to 6 times faster. And the allocation overhead is, according to this anyway, 50 to 100 times faster. So back to my original point, the ROS 2 system is essentially operating slower than the human nervous system and sort of conscious construct. If we believe this to be true, using some random thing Martin asked me on a random Tuesday afternoon, using a website and just a really brief sort of prompt and really in-depth PRD, we were able to create arguably, I'm going to use the word arguably, the world's fastest robotic system.
Do you feel that you lose anything in regards to testing where the system is testing virtualized hardware, and when it comes on actual hardware, there may be some degradation or any loss?
Hard to say.
Yeah.
I'm going to give you guys this. So someone smarter than me can go and fool around with this here. Let me pop this in the text chat. And here you go. I'm sending you the hello robots. So I don't know. Like I said, this is how I vibe code, right? I don't know. This could be an elaborate ruse. It could be full of shit. I have absolutely no idea. But what's cool about this is in order to run this, because I did the compilation of the Rust to a TypeScript. If you want to invoke this robotics, you don't need to go and use some convoluted ROS 2 sort of Python meets C++ interface. You can literally just define this using either my MCP or some TypeScript, right? So here's a swarm intelligence. So let's say you want to create, I can see some really nasty uses for this, but let's say you want to create a swarm of drones. This creates a self-optimizing swarm of drones. You can see here it's using my agent DB. It's creating 2D vectors. Here's vision tracking. Here's a robotic arm manipulation. Back to home run hitting robot. This is how you create a home run hitting robot. Now keep in mind, TypeScript's going to give you overhead. Now if you want to run this ultra fast, skip the TypeScript and just use the raw libraries, which you'll see in packages. Where's that? Crates, here it is. So these crates, this is the basis for the sort of core intellectual capabilities of the system. And we can see some of the code here. So we go to the core, we can see the messaging bus, the libraries, services. Lots of work to be done. I'd have to dig deeper, but for those who are interested in robotics, any comments, Guy?
Any comments, Guy? So is this actually working thing, or like it is you have tested the time frames?
I know. I have no idea. I'm just looking at what I built the other day. I need someone like Martin to go plug this into a robot. And if it takes over, it's Martin's fault.
Then publish it.
Yeah, we can try one more thing. Try to integrate like rather than normal bits, right? What if we try to integrate quantum bits, quantum algorithms?
You don't
So
need
it's
to.
like
You don't need to. Yep.
for speed.
Quantum isn't needed for any of this stuff. So, and it turns out that, at least in my opinion, take it with a grain of salt, but the benefits of quantum mostly has to do with speed or the temporal dynamics of computing. So the idea of quantum essentially was this idea that you could solve really complex problems by sort of parallelizing them and getting all kinds of answers to that problem all at once. And for certain things like like crypto or whatever, you're going to get you have to use quantum. But for the things that I'm doing, I'm saying, well, you can get some of the benefits of a quantum-based environment by operating super fast. So when you look at like nanoscale structures, the what do you want to call it, the causal loop between what's happened, what's happening, and what's going to happen.
Basically, I think quantum computing is trying to simulate the predictable nature of AI models because it is predictable in its own sense, right?
Yeah. So speed trumps broad, expensive sort of brute force. GPUs and quantum brute force the answer, and essentially temporal structures attempt to do a sort of concurrent parallelization of the problem. Many really small targeted sort of answers to questions that are happening beyond the sort of our ability to see and understand very fast. So for the things I'm doing, I wouldn't use quantum here. It just doesn't seem like it would solve my problem. So I'm just trying to get better, faster compute. All right.
Have you tried vibe coding using some browser model coming out, right? Browser agents. So have you tried like Comet? Have you tried using Comet for vibe coding using Claude Code? So it's like an agent trying to prompt engineer.
Yeah, exactly. You're thinking exactly like how I'm thinking. Yes, 100% I am, and I'll show you how to do that. All right, and again, before anyone complains, yes, I know it's like a beta or whatever. Not everyone has access or whatever, but here's the Claude browser extension. I'm not sure why it's taking so long to load.
Ruva, I have a question about the creation. When do you just ask Claude to generate PRD, and when do you utilize the swarm research for PRDs?
When do I ask Claude to do the PRD? Sorry, say one more time.
I think in the robotic example, I think you just ask Claude to create the 20 years from now version. But there's also a whole tool you created for swarm research. So when do you just ask Claude, and when do you actually utilize swarm research?
I like the interface for deep research for Claude, just because it's pretty and I can see these sources and it works. I basically kind of reverse engineered this a little bit for my research swarm. So essentially, in this particular scenario, when I'm creating a PRD and I'm vibing, and I'm totally vibing, you can see the simplicity of my prompt. I didn't dig particularly deep, and it ran for an hour. And in this case, then what I might do based on this PRD, then the first step over here might be to actually go and do another sort of verification step, because now I need to know that, let's say I'm doing cancer research. I need to make sure that, or a legal document or something, I need to make sure that this stuff is grounded in factual, components. What the Claude system doesn't do particularly well is certification and validation of the citations themselves. Now it gives me a whole list of things here, but it's not cryptographically signing them and verifying and showing me how, where, and what. So it's broad. And when you see that, when you go back to my these documents here, they're not particularly well defined. So then I might use my research swarm to basically go and validate it. So that'll be the first step, and then that would run for another hour or so before I get to the point of implementation. So it's usually a multi-step process. Now, the other thing you can do here, to the question of can you get Claude to basically manage the entire sort of structure? Yes, you can. So check this out. So now I'm using the Claude code or the Claude, whatever they call it, browser extension. Now you see here that I've got, oh, I don't have this. This is a new computer. Let's see what we got here. Yeah, I don't have. So I'm going to create a shortcut. Now we're going to call this, goal. Now what we're going to do is we're going to jump back into one of my VS codes for a second. Where do I have that? I got too much stuff going on here. Fidelity, actually, sorry guys, I got too many windows open. Which one is it? No, Neural Trader. I'm going to show you guys Neural Trader too here in a minute. So I'm going to start that. This will segue into the neural trading stuff I'm doing, which is all the stuff you just saw applied to stock trading. So let's but before I do, I'm going to show you how I can get the Claude to manage Claude. I got to give this a second to start up. And so you guys can do the same thing I'm about to do as well. Hopefully it speeds up.
Actually, I tried the same thing using Firebase. You know the Google's Firebase, right?
Yeah.
So I'm using Perplexity's Comet to wipe code using Firebase. So it is creating a full stack testable app.
Yeah, but Firebase has an API. So the problem with Comet is and the problem with Claude, which does pretty much exactly the same thing, is it's just slow. Now I'm trying to get, I'm gonna actually I've got something else open. I'm gonna show you guys instead. All right, so I'm going to agents, and so now I've got my Claude Flow installed. I've got my different folders. I'm going to goal. I'm grabbing the goal planner. I'm gonna copy this goal planner agent, and then I'm gonna go back here. So again, just to recap, I've got the extension here installed. Then I click the settings. All right, now I'm gonna go back here. And my computer is slow. It's a brand new computer. Why are you being slow? Yeah, maybe I should close some stuff down.
What'd you buy?
Oh, I got the new Asus Zen Book Pro dual screen jobby. I like lots of I got lots of double screens actually. All right. So now I go here. I'm gonna pop this in here. So this is my goal. So what this is a goal-oriented action planning system. It basically does dynamic planning, it does effective prediction and various goal decomposition. So it gives me the sort of secret brains. I'm going to create that. Then I'm going to go back here, and then I'm going to do slat. Yeah, you know what? It's this extension that's slowing it down. Anyway, I'm not going to run it. Maybe I will run it. Goal. Yeah, it's totally slow. Claude, you can in fairness to them, they did call it a beta.
So if you had added that as a skill versus the shortcut, would you still have to come back and add the shortcut also?
The extension doesn't have skills. That is a skill. That is a skill. So you can add skills directly to Claude, but the browser extension option doesn't use it.
Got it. Okay.
All right. So now we do goal. So it basically inserts the giant prompt, and then you know what? I'm gonna just say find new novel medical breakthroughs. And let's just see where we are quickly. I'm gonna scroll to the bottom. It's found. Oh, this is actually the robotics one. Okay, let's do optimize and prepare the ROS free traits and npm for publishing using the Claude.ai code UI, something like that. So I've given it the ability to operate autonomously with my goal prompt. And now I'm going to go and I'm just going to click act without asking, which is probably dangerous. And I might go below 72, 972, we'll see. And now this will organize and manage the Claude code system. So if you want this thing to run for a really long time, like days or something, this is how you're going to do it. All right, so now it's doing its thing. It's taking a screenshot. It's gonna figure out what it needs to do, and I'm just gonna let it run for a while.
Will it be performing unit tests also?
Yes, yeah. So my Claude, my agentic flow system includes the test-driven development London school, where it does sort of a test-driven development framework. So that's already built in. And I saw that when I went to the Vibecast folder. We went here.
And there's one more thing. The Claude browser which you're trying to use, will it know how to prompt engineer another AI model? Will it
Yes.
have the base of prompt engineering?
That's what my tools do. It inherently knows how to do a kind of meta prompt. So it just kind of magically works. All right, so this one we're gonna let that go for a while. All right, I'm gonna jump to NeuroTrader. Actually, before I do, any questions on what you've seen so far? I've been going fast, and hopefully it makes sense.
Can you put the goal planner shortcut into the chat just so we can drop in and create our own /goal?
Yeah, so the goal play, there's a couple different ways to handle it. So if you want to copy and paste it, you can well, actually, you know what I'm going to do for you guys? I'm just going to give you that. So let's go back to all right, let's just go to Claude Flow. We'll go here, and then we go to .claude, and we go to agents. There you go. And you can copy any of these agents. I'm going to pop this into the text area for you guys. Oh, I got to find where that went. Chat. All right, there you go. And just go into one of the folders. You'll see here goal. What to do. And this is code oriented. This is the one I use most frequently. Click the copy button, and you're good to go. Just copy it right there. And you can pop that into, you can also make a skill out of this. If you save this, so if you choose to download the raw file, save that as a zip, then you can go in the Claude under, where is it? And I think it's under settings.
Yeah.
And you can go to capabilities. Yeah, and you can upload skills. So you can see I've got.
What's the difference between this and the Research Swarm NPX?
The Research NPX is way more the Research NPX runs forever. So Research Swarm, there we go. So if you're curious about that, essentially this will run indefinitely. So what happens with the Claude Flow Deep Research is it can run for hours. Like I've seen some run for more than 2 hours, but eventually it ends. This, on the other hand, this Research Swarm never ends. Like if you set it up with a stream of data, let's say I'm going to show you guys my NeuroTrader here in a minute. The system you can get let's say stock market information or crypto or whatever you're looking to invest in, or even a fire hose from like X or some social media network. It'll study that in real time, learning and adapting and getting smarter without ever ending. So it's always researching indefinitely. Now, the drawback is that can be expensive if you're using expensive models. That's why I include the option to run local models that don't cost you anything. So in that scenario, all you really need is a GPU or potentially even a CPU, depending on the level of fidelity you're looking for. And it'll just run and run and run until it makes the decision. Then it'll say, oh, I've been running for 2 weeks and I just found the optimal stock trade. It can do that stock trade in under 100 milliseconds based on 2 weeks of training. So it's always learning, always adapting, and always getting better. So you've got, and that's what the Research Swarm does. Now, if you don't use the midstreamer, then it's going to end. Midstreamer, midstream, I think, yeah, midstreamer. Did I make it? Yeah, midstreamer is the low latency streaming toolkit. So temporal analysis toolkit. Well, it sounds like Johnny Mnemonic here, but this is basically the tool in which I'm using to sort of inspect the stream of data. So I'm looking at the data, finding bits and pieces. I'm using that also as the way I handle the AI defense AI defense system. So rather than learning about, cancer research, what the AI defense system is doing is inspecting the flow of information in real time to figure out what private information is leaking, what keys are potentially leaking, and then or even using a sort of the potential of sort of psychological tactics. It's learning how you potentially are being manipulated or your system is being manipulated. So it's attempting to hack itself with a real-time stream of information. And you can see here, I can do detections, in this case, under 0.015 milliseconds. So we're talking hundreds of microseconds, I guess, at this point. So you can do that concurrently, blah, blah, blah. It's just nuts. So all these tools are built in as a kind of Lego building blocks that one tool connects to the next tool, connects to the next tool to create each of my new tools. So when you go, if you want to see all the bits and pieces of this, which is actually I can even get to my jujitsu one yet, but basically these tools are all components. So when you see agentic jujitsu, I'm combining all the things I'm showing you into new and interesting new applications. In this case, this is a high-speed mechanism for thousands or potentially millions of agents to concurrently work on the same information. So I've got low latency for inter-agent communication. I've got the ability to see the information flowing to and from different agents in real time. I've got the ability to learn from that in real time. I get the ability to adapt based on the learnings of that in real time. So I can take all these pieces and make new interesting sort of components based on all my various other components. So now when you look at my recent updates, this is the sneak peek into the stuff that I'm building. So now we're going to get into how am I going to do the stock stuff. So before I ever get to posting the MPX or the MPX and NPM, you'll see here I've actually posted a bunch of my components that I need to do, high-speed neural trading. So in this case, the NT core, which is basically my NeuroTrader core, it allows you to do zero copy serialization. So similar to what we saw in the robotic system, I need the ability to basically figure out the optimal trading strategy before anyone else does, right? And right now, the limitation for stock trading predominantly is two parts. The speed of light, can I front load between New York and London, basically, and make the decision faster than somebody else? The faster than somebody else part is essentially where the world of quantitative trading comes into play. Most of the people doing quantitative trading right now are working in tools like Julia. They're using C libraries. They're trying to get as close to the sort of hardware as possible. And some of the best traders are doing an amazing job, and none of that is made publicly available. So if you happen to work at a large bank and you're doing this and you're a recent graduate from MIT, this is how they're doing it, but most people don't have access to it. I'm crazy, and I said, let's give everyone access to it, and this is what this system is doing. So we're talking the ability to do, financial calculations in nanoseconds or microseconds. It's type safe, so it's easy to use. You don't have to be a genius. Basically, point your favorite agent at this, and so these are all the various parts of it, right? So we've got, what else we got here? We've got these are the extractions. This is the market data component. Now, I haven't put this all together yet because I'm essentially giving you the building blocks to sort of Lego assemble all the various bits and pieces. And what's Guy sending me here? Flat buffers. Here we go. We can add that to the mix. But anyway, back to my rant. These are all the parts, right? So you can see I've got different, I'm using Alpaca and all these different parts. I didn't bother with too much readmes because eventually what I'm going to do is essentially make this available as a compiled package, which is what we're going to see now. All right.
Question,
yeah.
Which of the components that you've built do you consider to be the foundational layer? Is it AgentDB? Is it Claude Code Flow? Then you build, and then whoever would build on top of and use the other parts. If any. Yes.
It's right now the part that's probably the most valuable. I don't know if that's the right word. The most that has the most impact for what I've been building is definitely AgentDB. AgentDB is essential of all the things I've built recently is by far giving me the most impact, right? This allows me to do reasoning. Thank you, Google. This allows me to do various types of learning plugins based on self-selection of the best and optimal learning patterns. And I can spin these up across parallel agents that can try all the possibilities of all the different ways to achieve or solve a problem. And I can do that in ridiculously fast periods of time, right? So I've got the quick sync, again, the UDP component, no handshake, instantaneous communication. I've got MCPs, so I can plug it into Claude without a whole lot of effort. And I deliver it as a universal runtime. So you don't have to worry about compiling. All you need to type is npx AgentDB, and you suddenly get the system that's capable of doing all these crazy things and really, really quickly. So if you want to start and you want to create something crazy, point at AgentDB and say, go learn how to do something. And it's kind of like the Matrix where Neo plugs in and suddenly knows how to do jujitsu or something, right? It's got that kind of capability. So, and I know I probably should call it something to AgentDB. I think the DB does a sort of disservice to it. It is based on a vectorization, but it's more than that. It's basically this idea of a kind of vectorized synaptic network that doesn't require a sort of neural structure in the way that traditional neural networks operate. So I get all the benefits without
Like a
any of the
knowledge
overhead.
graph.
Maybe agent baseline or something.
Yeah, it's like a high-speed graph, is what it is.
You know what will bring all this together is if we go back to your original prompt that you used for the medical research swarm, right, is actually using all these things together. So you're basically installing Claudeflow plus AgentDB plus Research Swarm to find a novel medical discovery. And so it's using all of these in combination, right? So it's basically the Research Swarm is going out and doing that research, but it's using AgentDB to store everything that it's learning, which makes it immensely faster, correct? And better.
Yes. And yes, yeah, exactly. It's hard to even describe. Like it sounds like science fiction for the most part. So back to
before because someone's said graph, I meant to ask what is your view on basically VectorDB versus graph? I mean, the way I see it is that if you are exploring, if exploration over like repeatability or traceability, I mean, VectorDB obviously is what we use, but from a production like an enterprise where probably explainability is more, there's some work being done on graph graph work. What is your view and where do you stand on those two?
I'm not sure if I quite understand what you're asking me. You're saying like
the knowledge graphs
better?
Basically proper knowledge graphs rather. So in VectorDB in AgentDB, for example, you got patterns you are basically capturing the patterns effectively in the AgentDB implementation. That's how I have understood versus proper knowledge graphs, which is
I'm using a hypergraph, just to be clear. So most graphs, and graph experts probably gonna call me out on what I'm about to say, but most graphs are basically bidirectional, right? You've got an edge and you've got sort of some data relates to it, and it's a kind of one-to-one or potentially one-to-many, but it's still one thing connected to many other things. Now the part that I'm attempting to do is a many-to-many multi-dimensional structure, which I think sometimes is referred to as a hypergraph. The hypergraph allows for the structure to exist within both time and space. Okay, so time and space. Again, sound like a nut job describing it that way, but that's what it's doing. So time, temporal, right, is what's happening over a period of time, and as time elapses, you've got entropy. Entropy is the accumulation of chaos, right? So the faster you operate, the less entropy you get, the less chaos. There's essentially an algorithm that essentially measures that. It's called Lupinov I think it's what it's called. And what that does is essentially measures the amount of empathy that gets created over time. So when we go back to the concepts of there's a accumulation of complexity or chaos, the longer something runs, the harder it is to sort of make predictions and understand that information. So the shorter the period, the more tightly bound that is within the structure of what you need to understand. That's why the nano and microseconds are so important, because you can essentially understand cause and effect much more effectively because it's such a short period of time. So within the structure of the graph is defining not only that temporal element, what's happening, how quickly it's happening, and the accumulation of complexity, and then defining a structure to understand how that relates to everything else that's happening. So in this case, you've got multiple agents doing multiple things concurrently. They're writing files, they're researching, they're figuring out what's good and what's bad. I've applied the idea of reinforcement learning to that entire crazy concept that I just described around time, that says as it operates, not only is it understanding what it's doing, what the ramifications are, cause and effect, causal loops, I'm also training the system to give it a point structure, 20 plus, -15, to a maximum of 0.095 or 95%, or a minimum of 0.05, half a percentage point, until you reach a coherence, meaning that it does the thing in which it's supposed to do predictably every time. That's all happening in the structure of essentially the combination of AgentDB and all the other crazy stuff I've been showing you guys. And
So
it
how you're
works.
applying this reinforcement learning?
Yeah, it's machine learning. It's basically, it's vectorized temporal hypergraph machine learning. That's what it is. So
do you see this as an alternative to RAG or GraphRag, or fine-tuning a model on private corporate data?
No, it's an augment to it. So when you go to demo, one of my demos here actually is a RAG self-learning. So and this is a rudimentary implementation of it, but if you go in and you look at the inspector here, you'll be able to see kind of what it's doing here. But basically, what's happening is, as the RAG requests are being made, so I'm making a retrieval augmented generation. I'm requesting information from some secondary source. Generally, that's probably a vector or something. Then what I'm doing as part of that process, I'm learning based on the requests that are being made, so that gets better as those requests are made. Most RAG systems don't get better because they're essentially, using an LLM that doesn't allow it to understand the cause and effect of what it's being requested. It's just getting the information, inserting it, and giving it to the LLM, and the LLM is saying, okay, here's what you need to know.
Where are you storing the learning?
I'm storing in this example, I'm storing it as a SQLite database in the end user's memory on their computer. In this example, I'm actually storing it in the memory folder here in MemoryDB. So in MemoryDB, you'll see here I've got a pattern embeddings. Each of these pattern embeddings has a binary that I can compile that includes different bits of embeddings relating to all the things I was just describing, and that can define different patterns that can be found. It can define memory entries. So in this case, I got 379 pages. And there's how many per page here? Yeah, there's 37,891 memory entries for me building my system. So as it builds, it's learning and tracking everything it's done. Now, the important part here, this is RAG, basically. Before I make a request to do something, the system can understand everything that's happened to lead to where it's currently at. So now, 37,892 entries later, the system is basically been pre-trained on what it needs to do to effectively build the things of which it needs to do. But because I'm able to request it in this really, really fast structure, like milliseconds or microseconds, it doesn't affect the speed of the overall system. Basically, it acts as a kind of intermediary request that is made before it goes and says, hey, LLM, I need to know something. If I've already answered the question 37,000 times, I don't need to go to the LLM. So back to the agentic, do I have a page for that? Let's go to Rube.io for a second. I think, and I hope this, I'm rambling here, but hopefully this makes sense. Back to agentic flow. Oh, I'm on my projects. Agentic flow has yeah, here we go. This has a proxy. Oh, I don't know if I put it on this page. I probably have to go to where did I put that? GitHub, possibly. So the proxy, I don't know why I didn't include that in my documentation. That's an important part of the system. But anyway, the proxy essentially is a local proxy that everything flows through in high speed. So before the request to a given LLM or third party is made, it flows through your local proxy. Now that local proxy can then say in real time, because of the things I was showing you earlier, midstream and others, it can automatically say, okay, I don't need to make the request to the LLM because I've already know how to do the request because I've done it 1,000 times before, or I know that this request is going to fail because I've already done this and the request resulted in a bad piece of code that failed, or whatever else it needs to learn. And I'm not specifically telling it how to learn, it just kind of magically learns. And that's the self-learning capability. So the first time you use it, it's going to be basically the same as just making the request to the LLM. But the 38,700 and whatever time, it's now got all this information that it's learned, and it can do that in an instantaneous fashion.
Ruth, how do you add it to the Claude Code flow or Claude Code?
Yeah, so yep, you're going, oh, this is still running, by the way. But yeah, boom, just tell it to do this. NPX use the NPX agentic flow now, and do something like tell me about it. Just tell me how this works, right? And it'll just, or Sue, yeah, no, sorry, you got my idea. My dyslexia is showing. Use NPX agentic flow, right? And yeah, and it just works. Now, what you're seeing right now, I'm totally jumping around, but what we're seeing now is Claude managing Claude. Right, which is cool, and this will run for a while as well. So now what we're doing is letting it sort of optimize. It's going to create a private repo. It's doing some stuff. Whatever. I'm going to let that run for a bit. So let's go back to this for a sec.
Ruth, which database you are using for the embeddings?
This is a SQLite optimized database. And the trick to the SQL, and I also use Postgres and Supabase and whatever. SQLite is really useful for just as a sort of rudimentary interface between any database I want to use. But one of the things that's really interesting about SQLite, if we jump back here for a moment, in this case, we're going to go to AgentDB. AgentDB. So, oh no, I got a dedicated site for that. AgentDB is something called, it's called HS, yeah, I think it's HSW, I always forget the exact acronym. Where did I put that? Why is my brain not working today? I gotta find it. I have a hyper optimization of the actual, I gotta find where I put that. It's the most important part of the whole story. Why am I drawing a blank on its name? Sorry about that, guys. Here it is. There's a lot happening here. Here it is. HNSW. I just got my letters mixed up. Okay, HNSW. HNSW is what they call a hierarchical navigational small world, is a graph-based approximate near neighbor. This is the magic that makes it actually work in the ridiculously low latency capability. So it's designed for efficient similarity search in high dimensional vector spaces. Remember I mentioned they're calling high dimensional, right? I was talking about the multi-dimensional structure. It's used in applications like vector databases and other components. So this is the part that basically makes this is the magic. If you want to look at how exactly I'm doing it, this is what you need to look into. But what you need to know is I'm doing it. So and you can ask ChatGPT or whatever to tell you more about HNSW. And it's, yeah, and you know, Pinecone and others are using it. See what Wikipedia has to say here. Yeah, same information. They're really trying to sell us here. All right. We should add Agent DB to this list.
It's kind of
How
like
you're
PG
using
Vector
what you
for
say?
SQLite.
Yeah, you could use this with PG Vector, by the way. And oh my God, it's at the bottom of the hour. The hour went by pretty quick. Unfortunately, I got a hard stop today at 1:30. I got a call. Any final comments, questions, thoughts? I didn't get into my
the neural trader part. We'd love to hear more next time.
Next week. All the stuff I showed you is what I'm putting in the neural trader, and I'm gonna make it open source because why not? Live 1,000. Let's level the operating the world for everybody here. I'm gonna aim to get a first version out probably next week. I will release it. I'm gonna release it to the folks who paid for my previous neural trading sessions. You know, thanks for supporting me. You guys will get it first, and then I'll probably give it to the tribe.
I wanted to ask you, is this neural trading what you're talking about? What do you say, fast-paced quant trading type of algorithm, like type of things which industries do?
Self-learning. It's a self-learning trading system. So I've got the high-speed stuff, but to be honest, I'm working faster than most trading APIs can respond to. So at a certain point, I'm just too fast for basically any current modern trading system. So what I'm really doing
I think so there's this problem for sequential data that it doesn't depend upon the past, it only depends upon the current and the next output. So it's basically like a Markov chain.
Yeah,
kind
it's
of
Markov
thing.
chain. I am using Markov chains. Yes,
Oh.
100%. Yeah. So what it's doing essentially is it's really good at doing really small wins. So the investment isn't I'm going to make 10%, it's I'm going to make 0.01% above my fee, but I'm going to do it a million times. Right? So when you look at I can comfortably do the same profitable investment strategy across a whole variety of different verticals, and I can make just slightly more than it costs me to make that profit. But then I can get a swarm of agents doing that concurrently, millions and millions of times every minute. That so 1/10 of a million is actually a pretty good in return on
So
investment.
have you tested your profit and like loss? What is this pattern coming out?
I have, but I can't share that without security laws issues. So that said,
Yeah, sure.
use at your own risk. Don't spend more than you can lose. And I'm not a financial advisor. This is
No, I
meant
was just
as
asking like what
a
is a general
demo.
behavior you have observed?
Yeah,
What is general behavior?
you can, okay, long story short, you can take my NeuroTrader, pop it in the Claude Code web and say, go create me some investments.
So
And
it
that's-
gives you give the win
Okay.
rate on your site there, Roof. Do you know what the risk reward return is on it? Like what return you have on it? Because I don't think I saw that there.
It
I just saw
depends.
the-
I mean, to be honest, I'm going to lose that because I'm a little worried about securities, considerations there. All I can say is it depends on your strategy and what you're doing. Some people do really, really well. Others can't figure out how to make $1. And the only thing I can see the difference between those that are doing really well and those who don't is the ones that do well seem to have a background in sort of finance and trading, and they just basically take what they already know and apply it to the system. If you don't know what you're doing, you're not going to get any result. So it's almost like garbage in, garbage out.
Or like
So
gambling rather than trading.
it's gambling, yeah. So the folks that don't know what they're doing don't make any money. It doesn't change the nature of that. And I'm at the end of my session here, guys. I love this as always. Thanks everyone for tuning in. We're gonna do the AI hackerspace tomorrow at 12 noon. I share the Zoom, unfortunately, the morning of. Thanks, Dad, for joining us today.